Welcome to the Food Revolution Summit, where we explore how you can heal your body and your world with food. I'm Ocean Robbins, thrilled to be here for this next interview with George Monbiot. George Monbiot is one of the most influential and passionate environmental activists in the world. He's the author of many bestsellers, including Heat, How to Stop the Planet Burning, and Regenesis, How to Feed the World Without Devouring the Planet. In addition to his regular column in The Guardian, George's video, How Wolves Change Rivers, has been viewed over 40 million times, and Nature Now, co-presented with Greta Thunberg, has garnered over 60 million views. His life story reads kind of like an adventure thriller, including getting lost and barely surviving in the forests of Papua New Guinea, posing as a shipping agent to investigate the illegal trade in Amazonian mahogany, and getting beaten up by security guards while protesting a development project in Britain. In this interview, we're going to be talking with George about the environmental consequences of our food production systems and how we can be a part of the solution on planet Earth. George, thank you so much for being with us today.
Thanks, Ocean. Great to talk to you.
I want to start on a kind of sober note because we are up against some sober realities. Humanity is, one could say, on a resource consumption overshoot that appears to be putting us on a collision course with systemic environmental collapse. Can you speak to this and kind of lay out for us what we are up against?
People talk about what we're facing as being the sixth mass extinction because there's been 5 previous mass extinctions visible in the fossil record during the past 600 million years. But actually, even that is a kind of euphemism because mass extinction is what results from all the other things that are going on. What we're really facing is the 6th great Earth systems collapse. And in previous mass extinctions, we've seen a collapse of atmospheric conditions, a collapse of oceanic conditions, soil being stripped from the land desertifying. And that's what's caused those mass extinctions, among various other factors. And that's what is causing mass extinction today. We're seeing a massively higher rate of extinction of species than the usual background rate. But this is a symptom, a result of something even bigger, which is all these Earth systems, the atmosphere, the oceans, the cryosphere, the Earth's ice and snow, the soils, the forests, the freshwater cycle. All of these crucial complex systems, we're pushing them towards their tipping points. And all complex systems have tipping points. And when they hit those tipping points, they don't change slowly and gradually. They collapse into a new equilibrium state, which is likely to be hostile to human life. And together, those various systems form the Earth system, which is a sort of meta-complex system. It is a complex system of complex systems. And we're hitting it with every single possible assault. I mean, people talk a lot about climate issues, and so we should. What's happening to the atmosphere with rising concentration of greenhouse gases is extremely dangerous, but it's not by any means the only impact. We're flooding Earth systems with synthetic chemicals, most of which have never been tested for either their environmental impacts or their human health impacts. Even if we got everything right and still got the soil wrong, we are kippered because the soil produces 99% of our calories, and yet we are stripping soil from the land at the most phenomenal rate. And we see soil degradation and erosion taking place around the world at really dangerous levels, which severely threaten food security. We're maxing out the use of fresh water. And in many places, freshwater resources are beginning to fail. And they will fail catastrophically in some parts of the world at current rates of use. Because of global heating, the ice caps, the snowpack are disappearing very fast. And that not only means rising sea level, but it also means very different global weather systems because they regulate global weather to a large extent. And one of the things they do is to regulate the circulation, currents moving through the ocean and through the air. And that circulation is absolutely essential to our well-being and the well-being of our ecosystems.
A baby born today will be in their 70s at the turn of the next century. If we continue on our current course, tell us some of the challenges that they and their friends might be facing at that time.
Well, to put it crudely, very large parts of the planet are likely to be uninhabitable by then on current trajectories. Unless there is a very sharp change of direction, we're going to see billions of people left outside what is called the human climate niche, the parts of the world where humans can live. Now, at the moment, a very tiny proportion of people live in extremely hot parts of the world. And by extremely hot, I mean an average temperature of 29 degrees centigrade. That's as hot as the hottest parts of the Sahara Desert. But if we continue on this trajectory, we could see billions living in places that hot by the end of the century. And in many places where you've got a combination of high temperature and high humidity, it literally becomes uninhabitable. A human body can't stand it. So there's something called the wet bulb temperature, which is the temperature at 100% humidity. And beyond the wet bulb temperature, the human body just fails. And that's because when you've got high humidity and high temperature, you can't lose heat by sweating or by radiation. The two functions are shut down. And so the wet bulb limit, the absolute limit, is about 35 degrees centigrade, which is just a couple of degrees below our body temperature. And you can't radiate enough heat. And if it's 100% humidity, you're not going to lose the heat through sweating either. Most people would die sometime before it reached 35. But now in several parts of the world, we're seeing wet bulb temperatures just occasionally spiking above 35, but quite often coming pretty close to it, and large numbers of people dying as a result. And that's going to spread, and there are going to be more and more parts of the world where it's simply not going to be possible for a human being to live there. Even wider parts of the world, it's not going to be possible to grow crops. It's going to be either too hot for the crops, there won't be enough soil moisture, there'll be much more severe droughts and other shock events, including cyclones, hurricanes, fire, all of which can be devastating to crops. And we will see, with rising seawater and shrinking freshwater aquifers, the sucking of seawater into the ground, poisoning those aquifers and making it impossible to irrigate the crops. And so we see combinations like that. And then on top of that, we have the soil erosion. On top of that, we have the collapse of marine food chains. On top of that, we have the potential collapse of massive earth systems like the Amazon rainforest, which gets eroded and eroded until it can no longer generate its own rainfall and flips suddenly into savanna conditions, and then changes climatic conditions right the way around the tropics. So all of these frightening converging forces are likely to materialize by the end of the century, unless those of us who are alive and adults today change the system.
And that is why we are here. So if anybody watching is feeling just a wee bit depressed right now, you're not alone. But we're here because we can do so much. The past doesn't have to equal the future. And just because we've acted in a certain way to this point does not mean we have to continue acting this way forever. We need to, however, face the reality of what we're up against if we will be compelled to engage with the urgency that is required to turn the ship around. And that's why we're here. George, you wrote an article about plutocrats versus life on Earth. Can you tell us what this article is about?
Yes, so that basic theme is the theme of most of my articles, is about how economic power overwhelms political power. In other words, money trumps democracy time and time again. The power of money in politics is one of the most dangerous forces on earth. It's what stops us from getting what we need, stops us from solving our problems. And in that particular article, I was looking at the complete failure to get to grips with the possibility of what's called multiple breadbasket failure. And multiple breadbasket failure means several regions of the world which produce large amounts of crops, which are very important to our crop production and therefore to our survival, all suffering harvest failure at the same time. Now, we've seen some significant parts of the world suffering major harvest shocks recently, but we've been lucky in that those have tended to happen in isolation. There'll be a serious impact in one major breadbasket, as there was, for instance, in India, where the wheat harvest largely failed, and India had to cancel all exports of wheat. But it didn't coincide with similar failures in other parts of the world. And so we survived through a kind of global smoothing. You can have a failure in one place, but as long as other places are still producing plenty of food through trade, through aid and famine relief and the rest of it, you can move that food around and ensure that everyone can be fed. But if several of the major grain growing regions fail at the same time, you can't do that. And then we're in very serious trouble indeed. And I was writing in particular about a paper which proposed a mechanism by which this could happen, and it's a very likely mechanism because we've seen hints of it already beginning to occur. And this is basically a pattern of waves in the jet stream. And the jet stream is an air current which goes around the northern hemisphere. We're talking about the northern current here. And it forms these waves called Rossby waves, which as the planet gets hotter, those waves tend to get more extreme and more likely to get stuck. And basically stuck weather is extreme weather. It's when the weather's the same day after day after day that temperatures rise, or for that matter, temperatures might fall catastrophically. But it's what creates severe weather is when it doesn't move on. And when it gets stuck in a pattern, depending on which side of the wave you are, if you're north of the Rossby wave in the jet stream, it's likely to be particularly cold and wet. And if you're south of the Rossby wave, it's likely to be particularly hot and dry. And both extremes can be very damaging indeed to crop production. And in fact, we've seen several parts of the world recently get stuck on either side of that Rossby wave and suffer as a result. But if it forms a particular pattern where it leaves some of the major regions like Western North America, like Eurasia, like northern India, literally high and dry on the south side of the Rossby wave where it gets hot and dry, then we could see that harvest failure happening bang, bang, bang around the world. And then we're in serious trouble because we don't have that much stored food. You know, there's that would be sufficient to trigger a net global shortfall in the food that we need to eat.
In 2022, we got a bit close there between the war in Ukraine and all of the disruption of food from a region that produces, I think, 12% of the world's calories, but also with the harvest problems in India that you described, food prices were skyrocketing. We didn't actually have massive global famine or starvation in that time, but we got close.
In fact, it was a very good example of how a geopolitical and an environmental crisis can come together, because March 2022, India said, don't worry, you know, we'll fill the shortfall because we've got a monster wheat harvest on the way. We'll make up for the wheat that you're not getting from Ukraine and Russia. And then literally just a month later, in April 22, they said, oh, about that wheat harvest, it's all shriveled up and we're not exporting anything now.
So let's talk a little bit about agricultural systems and how they are fueling this crisis, and also how they could create a different kind of possible future. Let's start with the bad news. How is industrialized agriculture and industrialized animal agriculture at the forefront of fueling the crises that we're discussing today?
Food production is the top cause of environmental disaster on Earth. And it's something which we don't really want to talk about very much. We're much happier, more comfortable talking about, say, fossil fuels because, well, they're the baddies, aren't they? But we like farmers and we depend on farmers and we need the food. And we need farmers to stay in business, but we urgently, desperately need to do things differently because food production is the top cause of habitat destruction, the top cause of wildlife loss, the top cause of species extinction, top cause of land use, which is a crucial issue, top cause of freshwater use, top cause of soil degradation, and one of the top causes of climate breakdown, water pollution and air pollution. And yet, we don't want to go there. We don't talk about it. And overwhelmingly, the major contributor to those problems is animal agriculture, because it just takes a lot more to produce a given amount of calories from animals than it does from plants. A lot more land, a lot more crops if you're feeding them with crops, or even more land if you're feeding them with grass, because that's quite a land inefficient way of producing food. And so you have to occupy vast tracts of the planet which would otherwise support wild ecosystems. If you're producing meat from grazing animals, it's actually even more damaging than producing meat from intensively fed animals. And it's by far and away the biggest contributor of greenhouse gas emissions from agriculture. In fact, animal agriculture alone causes more greenhouse gas emissions than all the world's transport. It's second only to fossil fuels. And the real fear here, the real danger, is that the demand for it is just growing and growing worldwide. The livestock population is growing much faster than the human population. I mean, people talk about a population crisis, but actually human population is one of the very few environmental metrics which is plateauing. It's slowed right down. Population growth fell below 1% last year for the first time probably in a couple of 100 years. It's really a remarkable thing that has changed, and it's slowing towards zero. But animal numbers, livestock numbers, are just growing and growing at 2.4%, which means a doubling every 30 years. And it's already the case that of the weight of mammals on Earth, just 4% are wild ones, 36% are human beings, and 60% are livestock. And then that's going to double, by soon after 2050 at this rate. Then it'll just be 2% of the weight of mammals on Earth being wild. It's a terrifying prospect. This is what's eating us out of house and home. And, just as importantly as leaving fossil fuels in the ground, we have to stop farming and eating animals.
If, just theoretically, the whole world went plant-based tomorrow, what would change?
Well, for a start, we would release about 3/4 of the world's farmland for rewilding. And I think now that rewilding is our only hope. It's the last hope we have. The mass restoration of ecosystems, bringing back the forests, bringing back the wetlands, bringing back the savannas, the wild grasslands, all of which are much richer in wildlife and much richer in carbon than farmed landscapes. That rewilding would draw down much of the carbon we've already released into the atmosphere. We also obviously have to severely and rapidly decarbonize our economies at the same time. It's not enough by itself, but the two things together could get us there and could allow ecosystems to bound back. And if they do so, then we really could prevent the collapse of Earth systems. But if we don't do that, it's really hard to see how that's going to happen. And so that's why I think that ending animal agriculture is right up there with leaving fossil fuels in the ground, because of that enormous potential for restoring the planet, which we would have if we did that. It would also mean that the direct greenhouse gas emissions from agriculture would fall by about 3/4. So you're saving land, you're saving greenhouse gases, you're saving soil, you're saving water. I mean, everything gets easier in environmental terms if we switch to a plant-based diet.
I want to go a little further on this greenhouse gas emission equation. In 2006, the UN Food and Agriculture Organization came out with an analysis that calculated livestock's overall contribution to greenhouse gas emissions. And their original paper said livestock were responsible for 18% of all global emissions of all types. But then they subsequently revised that figure downwards to 14.5% in a follow-up paper. They're now revising it further downwards. George, have these downward revisions been based on valid science, or are they a reflection of industry pressure?
They really have not. In fact, there's been a series of revelations about the lobbying pressure from the livestock industry, the meat industry, bearing down on the Food and Agriculture Organization and changing the results. That should never happen in science. But unfortunately, the science is taking second place to the politics here. There's a recent independent study which put it more like a quarter of all emissions, about 25%. But the truth is that we don't actually have enough science to be able to state definitively this is how much it's producing, partly because of that industry pressure. You know, it's cut off the funding sources for the research we need to do. But what we can say with confidence is that those Food and Agriculture Organization figures just do not stand up because they've been deliberately watered down through political pressure. And that's really outrageous. That's an insult to everyone. It insults our intelligence. It undermines our ability to solve our common problems if we can't trust our factual sources.
And of course, in the equation is that if we free up large areas of land, we don't know yet what we would do with that land. But if in turn we use that land in the optimal ways to sequester carbon and restore ecosystem vitality, then that becomes a powerful asset in the fight against climate chaos and environmental destruction. I want to ask you about chemical pesticides and fertilizers for a moment. Are these something that we need to feed a hungry world and increase yield, or are there concerns here?
We desperately need to reduce our use of both. I don't know if you're aware of the planetary boundaries model. It's a really useful way of looking at where we stand in relation to the living planet. It was developed by scientists led by Johan Rockstrom, and I find it a very useful graphic way of seeing where we are. And they sort of say, right, how much pressure can the world system stand? And here's the maximum pressure it can stand. And when you look at certain indicators, and particularly the two you've just mentioned, the use of fertilizers and the release of synthetic chemicals like pesticides, we are way, way past those boundaries, way past the limits. In fact, more so than almost any other indicator. It's a really worrying situation. So you think fertilizer, what's wrong with fertilizer? It's good for plants, isn't it? Well, yeah, it's great for growing crops, but the trouble is that it fertilizes everything. The whole planet has been fertilized with the phosphate that we've dug up from the ground and with the nitrogen that we've sucked out of the air and turned into reactive nitrogen, which is a very different matter, through industrial processes, the Haber-Bosch process. And that has just flooded the planet with loads and loads of these active chemicals, which then stimulates plant growth in all sorts of places where you really do not want to be stimulating plant growth, like in rivers and like in the oceans. And that creates blooms of single-celled algae, which can then kill the rest of life in those places. It's creating dead zones at sea, among other impacts. And the reason for that is that by day, the single-celled algae photosynthesize and produce oxygen, but at night they respire, suck up the oxygen and produce carbon dioxide. And in doing so, they basically asphyxiate whole ecosystems. And we see rivers dying, we see oceans dying because of this over-fertilization. And we also see soil ecosystems being very severely damaged. In fact, if you apply too much nitrogen to the soil, you think, we just slap the fertilizer on and that's going to be great. But you can actually cause the entire soil structure to collapse and then plants stop growing in the soil. So it has a paradoxical effect. It's useful up to a point. You get beyond that point and suddenly you're causing more harm than good. And so we urgently need to get away from that. Similarly with pesticides. I mean, we call them pesticides as if the only things they kill are pests, right? But many of them are like broad spectrum biocides. They will kill many of the life forms they come into contact with. And people say, look at the bees being killed. And yeah, it's a really frightening situation. But actually, the bees are just like one set of species. If you look at what's happening in the soil as a result of pesticides, it's killing entire food chains. And we're not even aware of that. We don't even think about it. No one's talking about the springtails and the mites and the nematodes and the other species in the soil being killed off, but they're absolutely essential. These are the species which build the soil. Soil is a biological structure. It's like a coral reef. And without the organisms that live in it, there is no soil. The soil disappears. And so right across the board, pesticides get into freshwater ecosystems, they get into marine ecosystems, they have all these impacts, most of which we're only just beginning to become aware of. They haven't been properly tested in field situations, let alone when they spill out into ecosystems they weren't designed for. So we urgently need to get away from this. But, and here's a real constraint, at the same time, we do need to keep food production levels high enough to support 8 billion people. It is, we do have to accept that the food system has done something pretty remarkable in that it has fed everyone. When I was born in 1963, people were widely predicting catastrophe, and not just because I was born that year, but there were at the time 3.2 billion people on Earth in 1963, and people said, look, the population is going to grow by X, but food production is only going to grow by Y, and we're not going to feed everyone. There's going to be mass starvation. But in fact, there's less starvation today than there was in 1963, when we had less than half the current population. There's 8.1 billion people on Earth today, and on average, we are better fed. That system is now running out of road, incidentally. We're pretty well hitting the buffers, and we see global hunger beginning to rise again, a very worrying sign indeed. So somehow, we have to do what that system has achieved, but with much lower environmental impacts. This is a great challenge we face, to feed the world without devouring the planet. And I think, and okay, I'm a bit biased about this because I'm absolutely fascinated and amazed by this wonderful ecosystem. I think the secret is in the soil. I think a much better understanding of the soil and the complex relationships between plants, bacteria, fungi, and all the other organisms in the soil can help us to increase production, or at least to maintain current levels of production, without having to slap on all these chemicals. We've kept ourselves alive through soil chemistry, but in the future, we'll keep ourselves alive through soil biology.
Absolutely profound. I almost want to underline that. We've kept ourselves alive through soil chemistry. In the future, we'll keep ourselves alive through soil biology. Thank you. What about for consumers and for farm workers, pesticides? Can you speak to the impact of them on human bodies?
Well, I wish I could, but again, it's almost a black box. We know a bit. There have been individual studies showing us that a particular level of exposure to a particular pesticide can lead to cancer, can lead to infertility, can lead to a whole series of other very grave illnesses. But what we don't know is the aggregate effect of all these pesticides and other synthetic chemicals that we're encountering. I mean, it's an absolutely shocking fact that 80% of the synthetic chemicals which are being released into the world have not been tested for their environmental or their human health impacts. I mean, it's such a massive failure of governance, that. I mean, that sort of stands almost, you can almost see it written on the sort of tombstone of humanity. We didn't test these chemicals before we released them. And so we've got very little idea of how most of them operate on the human body. We know from some very tragic cases that some of them are extremely dangerous to human beings. But what we have much less idea of is what the cumulative low-level exposure to a cocktail of these toxins is. And one of the things we're seeing is a very rapid drop-off in fertility. people having much more difficulty conceiving children, male sperm counts right down, female fertility right down. And we don't know exactly what's causing that, but the synthetic chemicals are a very strong candidate. In fact, they seem to be the most likely explanation for this very frightening trend. And it's beginning to look like Margaret Atwood's novel The Handmaid's Tale, where we're heading towards a point at which very few people can have children because of the toxic load in Earth systems. And again, there's this sense that we're just going at it blind. We're steaming into this situation without the knowledge we need to understand what the implications are.
One other aspect of industrialized agriculture, concentrated animal feeding operations, or CAFOs, tend to be heavily dependent on antibiotics to fatten animals up and also to keep them alive under deplorable conditions. Now they've become breeding grounds for antibiotic-resistant bacteria. Some might even say that in a sense they've become biological weapons factories, because in effect they're breeding bacteria that are pathogenic to humans. Can you talk about this issue?
No, it's a really important issue and another greatly neglected one. It's so frustrating. These things should be right in the front of people's minds all the time. We should be talking about these issues all the time. Instead, we're talking about trivia, about nonsense. It fills the airwaves. So I'm very grateful that we're having this conversation. Now, bacteria are amazing. They're really, really fascinating creatures. And the more you know about them, the more in awe you stand of these little tiny single-celled things. And one of the things they do is to produce these chemicals that we call antibiotics to fight each other, because they're constantly in competition. They're constantly competing for resources, competing for the attention of plants, which they're in the soil. They're in a crucial relation to, and so they fight these sort of chemical warfare battles, shooting each other with antibiotics. And a lot of, in fact, all the antibiotics we use are derived from those battles that bacteria fight. But we've identified only a small number, and they have a shelf life, and that shelf life is determined by how quickly bacteria become resistant to that chemical warfare, because that's another amazing thing that bacteria can do. They mutate and they mutate in order to get past the attacks of their rivals and to be able to survive those attacks, whereupon the antibiotics of their rivals become redundant. And that's what's going on in these CAFOs. What you've got is all these animals together in very close quarters, very prone to disease because of their proximity. And so they're being absolutely plastered with antibiotics prophylactically by farmers to prevent the whole lot from being wiped out by bacterial infections. Because once a bacterial infection takes hold in a place where these animals are so tightly packed together, it could kill the whole lot. It could just be a plague which wipes out the entire farm. So to prevent that from happening, farmers dose them prophylactically with antibiotics, which is something we never do in human medicine because antibiotics are such a precious resource. We're very aware of the need to preserve it, so we don't use it in such profligate ways. But also, they use antibiotics as growth promoters. It's really shocking. Again, this precious, crucial resource is just used to fatten up animals because for some reason, which I don't fully understand, it has something to do with suppressing gut bacteria. It makes animals fatter more quickly if you wipe out some of the bacteria in their systems. So it's just a grotesque thing to do. Anyway, not only do you have the chance of resistance forming among the herd, but even worse and more powerfully, all the manure that those animals are producing, all the dung, goes into one big pit or one big tank or one big lagoon, and it all gets mixed up together, and it's full of antibiotic residues. And so the bacteria living in that manure then have a very strong selective pressure to develop antibiotic resistance, because if they don't, they're likely to be killed by those antibiotic residues. And so you've got billions and billions of bacteria in there, all trying to be the first to come up with a resistance gene. Once one of them has acquired it, they do this thing called horizontal gene transfer, where they can swap genetic material so it can jump from species to species among the bacteria. Then we pump out those slurry reservoirs and we spread it over the fields. And so you're spreading antibiotic resistant bacteria right across the ecosystem, where they can be then get taken up on plants, they can flow into rivers. And we're seeing this happening. We're seeing the spread of these antibiotic resistance genes right the way around the planet. And that is a severe threat to human health. I mean, people don't appreciate the extent to which modern medicine is so dependent on antibiotics. You can't get safe childbirth without antibiotics. You can't have safe surgery without antibiotics. You can't have chemotherapy without antibiotics. There's so much of modern medicine is totally dependent on it. And without antibiotics, it's another existential threat to humanity, basically.
So many existential threats. And of course, a lot of people are saying, well, CAFOs are bad, obviously cruel to animals, breeding grounds for antibiotic resistant bacteria, terribly resource inefficient because it takes so much grain or soy to produce a pound of meat or dairy or eggs. So then they turn to pasture raised or grass fed. But you've been quite outspoken that this really isn't an answer. In fact, in some ways, it solves one set of problems, but adds a whole new set of problems. Can you tell us about why you are so concerned about the regenerative grazing fad, if you will, and what's really at stake here?
There was a study in the United States saying, what if we did what the foodies and the celebrity chefs are telling us to do and switch from CAFOs to pasture-fed beef? What would then happen if everybody did that? And it found that the amount of land required to raise cattle in the United States would rise by 270%. You would have to fell all the forests. You'd have to water all the deserts. You'd have to drain all the wetlands. You'd have to de-gazette all the national parks. You'd have to demolish all the cities. And you would still be importing much of your beef from Brazil. So there's just not enough planet to do it. Land is the great neglected metric in environmental thought. We should be thinking about the amount of land we use, because every hectare we use for our extractive industries is a hectare which can't be used for wild ecosystems. And the majority of species on Earth depend on wild ecosystems for their survival, but Earth systems themselves depend on wild ecosystems. So if we're sprawling across the planet, using more and more land to produce our food, then we're leaving less and less land for wild ecosystems, and therefore for our own survival. And by far and away the greatest human land use already is pasture-fed meat. That we use more land for that than any other purpose. We use almost twice as much land for that than all the protected areas on Earth. We just can't afford that. And if more people start wanting to eat pasture-fed beef, well, that would be fine if we had several planets and no room for wild ecosystems on any of them. But we don't. And it's one of the factors which is driving us towards Earth system collapse.
Is there a place in the world, in certain ecosystems, in which so-called regenerative grazing could make sense, not necessarily to feed humanity's current meat appetite, but on a smaller scale? Let's say, are there some ecosystems where that may be the highest use of them, at least from a human's perspective?
Yes, you can have very small numbers grazing without doing major ecological damage. I mean, and some ecosystems benefit from grazers. Ideally, it would be wild ones, but where all the wild ones have been wiped out, then you can have some ecosystems benefiting from having a very few livestock in them very occasionally. But that would produce a tiny fraction of our demand. And if that's where our meat came from, only multimillionaires would be able to eat it. It would be a super luxury product like beluga caviar or bluefin tuna sushi or something, and it would cost an absolute fortune. And so there's a lot of magical thinking here. People say, oh, we can have this conservation grazing and we can eat that way. Well, yeah, you can if you're a multimillionaire, but other people would not be able to eat meat if that were the case. And so basically, there's just no good way of doing it. There is no good way of supplying the planet with meat. It's either, if you go down the intensive route, it's a disaster. If you go down the extensive route, it's a disaster.
Speaking of costs, the European Union budget, I believe a fifth of it is going to subsidizing livestock production. Can you speak to this, and what is the real cost of meat today?
It's an extraordinary thing. I mean, and worldwide, probably about half of all agricultural subsidies are going to livestock production. And we spend as a planet between $500 billion and $600 billion a year on farming, on subsidizing farming, and over half, we believe, is going to livestock farms. This is a terrible waste of public money. This is your money. This is my money. This is money coming out of our pockets. We pay in our taxes, which is then being poured into sectors which are destroying the planet. It's like the subsidies for fossil fuel production, which is another totally perverse use of public money. It just should not be happening. We should not be doing this. But again, it comes down to the lobbying power of these very powerful big corporations, the meat industry, the livestock industry, the trade associations which represent livestock farmers and meat producers, which unfortunately seem to wield more power with government than we do as voters.
Yes, and of course we're working to change that, but these are powerful entrenched forces. And I want to just talk about one more dark side of this before we hopefully get a little more positive. Rainforests, tropical rainforests. A friend of mine, Tashka Yawanawa, is chief of the Yawanawa tribe in Brazil. Their homeland, their way of life is threatened by logging operations. What's the primary driver of rainforest destruction, and how does our food choices impact that?
So the primary driver is cattle ranching. And that's not just the case in Brazil, and people know about cattle ranching in Brazil. It's the case in Colombia, in Peru, in Ecuador, in Bolivia. It's the case in Madagascar. It's the case in Northern Australia. It's the case in Myanmar. It's in so many parts of the world. That is the big driver of rainforest destruction above anything else. We talk a lot about palm oil, and palm oil is a very destructive force which destroys a lot of rainforest, not nearly as much rainforest as cattle ranching destroys. It is the overwhelming driver of it. Of course, there's other factors as well. There's producing soy, the great majority of which is used to feed chickens and pigs and other farm animals. And that's very severely eroding the southern Amazon. There's cutting trees for timber. There's a general spread of agriculture in some places, agriculture of all kinds. But again and again, in many regions of the world and in total worldwide, it is cattle ranching that comes out as the top cause.
A lot of times we are told to eat locally grown food, and there's some compelling advantages to doing so. Local food is transported less far, which is less fossil fuel impact. It's fresher typically, and it can even be a way of investing in local economies. But at the same time, sometimes in some regions, the only food that's local in the winter, for example, maybe animal products or things from the freezer, of course. Can you speak a little bit to the pros and cons here and how someone might want to balance them?
Now, there's a lot to be said for local economies. They can be more accountable. They can cut out the middleman, so you can have a direct relationship between producers and consumers. These are good things, but it's by no means a magic bullet to solve the problems of the food system. In fact, it can do exactly the opposite. So, for example, I estimated that you would have to ship a kilo of dried beans 100 times around the planet before it had the same environmental impact as a kilo of beef produced in the field next door to your house. We have massively overestimated the impacts of transport and massively underestimated the impacts of the kind of food we are eating. And it can often be a much greener option to be importing plant-based foods from around the world than eating animal-based foods at home. In fact, in almost all cases, it is. There's an exception, which is food that is flown. And people assume that most of the imported food in their country is flown in. It's just not true. 0.16% of food is flown, and a lot of that is fish and shellfish. There are some plant-based foods which are flown, certain berries, for instance, green beans, sugar snaps, but they're a very, very small proportion. The great majority is shipped and trucked, and the impacts are much, much lower that way. Shipping in particular has become super efficient now. And obviously it'd be lovely if we could all grow our own food and do everything locally, but we simply can't. There was a study published in Nature Food saying what's the minimum distance over which the world's people can be fed, and the average minimum distance is 2,200 kilometers, about 1,300 miles. And the reason for that is that a lot of us live in very densely populated places where there's just not a big enough agricultural hinterland to feed us. So we do depend on food being moved around the world. And in fact, one of the reasons why we suffer so much less famine and starvation today is because of that global transport of food. Of course, it has downsides. There are plenty of downsides to that. And in a way, we become over-dependent on it, particularly as so much of that trade is now controlled by large corporations. You know, one estimate suggests that 4 corporations control 90% of the global grain trade. That's a very dangerous situation indeed. But we can do it better. You know, we're always going to be dependent on the movement of food to some extent, but we can do that better, and we can break the stranglehold of those corporations. In fact, we must do. Again, it's another existential risk, because when corporate power becomes over-dominant, the system can fail, just like it did with the financial sector in 2008, which was rescued at the last minute by governments printing future money, issuing future money in the form of quantitative easing. Well, if the food system fails, you can't print future food.
What about regenerative agriculture? It's kind of a term that's been linked a lot to beef, but regenerative agriculture at its core means making the soil better, not worse, and hopefully sequestering carbon in the process. Can you tell us your thoughts on what's possible here? Can we make richer soil and pull carbon out of the atmosphere and make more nutritious food all at the same time?
It's a real shame that this word has been so abused, because it should be a very powerful word, but a bit like sustainable, it's just become a word which people slap on to whatever they happen to be doing. So you've got regenerative ranching, formerly known as ranching. And it's just, you know, it's almost been completely devalued because of overuse. And there's no proper definition of the word, and so anyone can say, I'm doing regenerative farming, and just about everyone does now say that, regardless of what they're doing. You know, they're just doing exactly the same as they were before, but they're giving it a new name. But there are genuine regenerative things that can be done. And one of the questions you need to ask is, what are we regenerating? You know, if you're doing something regenerative, there has to be something which is being regenerated. You know, is it an ecosystem? Is it a water system, or is it a soil system, for example? Soil is arguably the most important of all ecosystems, and so it is very important to regenerate it. And there are techniques, there are systems which can rebuild soil while at the same time producing food. There aren't many of them, and it's really difficult. It's really tough, but we need massive learning now to see how those few examples can be generalized. So, for instance, I've worked closely with an amazing grower of vegetables here in the United Kingdom called Ian Tolhurst, or Tolly, who, farming on very poor land, it's 40% stone, has managed to raise soil fertility and raise his yields of vegetables without any fertilizer or any manure, or indeed any pesticides or herbicides, until he's hit the lower bound of what conventional growers produce using fertilizers, pesticides, herbicides, and all the rest of it. And he's done so by rebuilding the soil in some really interesting ways. And his key insight is that soils in this part of the world, right across Northern Europe, in fact, the soils we call agricultural soils are really forest soils. They're soils where trees used to grow. And they're much happier when they think there are still trees growing there. So either you grow trees with your vegetables, but that does cause some issues because they can shade out vegetables. You have to be careful about how you do it. Or you kind of fool the soil into thinking there are trees there by adding very small amounts of wood chip at strategic parts of the rotation. And when he did that, his soil fertility almost doubled overnight. And what seems to be happening is that he's tweaked the crucial relationships between plants, bacteria, and fungi. And those bacteria and fungi in the soil are the mediators of nutrients. The soil scientists call them the eye of the needle. Everything, all the nutrients has to pass through them before it can reach a plant, because it's them who, the soil bacteria and fungi, which release the nutrients from the soil. Because plants can't get to them by themselves. They need these intermediaries. And what, in a healthy system, where it's functioning, those fungi and bacteria do two things which are of equal importance. And in the scientific speak, one's called mineralization and the other's called immobilization. And mineralization means releasing minerals, and immobilization means locking them up. And what you want is a situation where they release minerals when the plant needs them and lock them up when the plant doesn't. Because if you're not locking up your minerals, when the plants are off the ground, they'll just leach away through the soil and your soil loses fertility. And he has managed to develop a system where mineralization and immobilization are happening at exactly the right moments. He's rejigged that relationship between the plants and the microbes until they're in that perfect balance where he needs them to be. Now, quite a few growers have managed to mimic what he does and apply it on their own farms with great success. And he's become a real hero amongst vegetable growers in this country. But some haven't been able to do it, and we don't know why. It's something to do with the soil. It's something we don't know about the soil. And there's so much we don't know about the soil. You know, it's almost a black box to us. We know less about that than arguably any other ecosystem. In fact, we know less about the surface of this planet than we do about the surface of Mars, because we have this incredibly complex thing called soil, and they've just got regolith on Mars.
I'd love to hear if you'd be willing to start and complete the sentence. The best way to eat for a healthier planet is, what would you say?
Best way to eat for a healthier planet is a plant-based diet, cutting out to the greatest extent possible all animal products, reducing your impacts, and at the same time improving your health by eating a diet which is very rich in vegetables and fruit, and where you get your key nutrients from plants rather than animals.
George, do you have hope for our species? And if so, what does hope mean to you?
So I do have hope, because I recognise that society is another complex system. And throughout this conversation, we've been talking about complex systems. All the things that are important to us really are complex systems. The human brain is a complex system. The human body is a complex system. The food system is a complex system. The financial system, every ecosystem, the oceans, the atmosphere, the cryosphere, they're all complex systems. The soil is a complex system. But human society is also a complex system. And complex systems have tipping points. They all have tipping points. And that applies to human society just as it applies to all others. And they can tip in a very positive direction when it comes to social tipping points. And we've seen that in many cases across human history where situations looked impossible. You know, the situation of women in the 19th century, you know, how would we ever get rights? How will we ever get the vote? It was just impossible. It was completely locked down. Patriarchy was like 100%, sort of iron bars everywhere. You can't get out of that prison. And then suddenly it changes, not by itself, but through very effective campaigning by women. And obviously there's still a long way to go. But, you know, what looked impossible in retrospect looks inevitable. And that's happened with many, many other issues, you know, whether it's civil rights, whether it's independence for colonized nations, whether it's the end of apartheid, whether it's gay rights, equal marriage, end smoking in public places right across Europe now, most of Europe. All of these things have happened starting from a situation where you thought that's impossible, that could never happen. The opposition is too great. This is just the way things are. It's just the way society is. You can't change it. You must be a ridiculous idealist if you think you can change it. And then afterwards, everyone said, well, of course, I always knew that would happen. Yeah, of course, it was bound to happen. Because, it's a tipping point. It tipped. And it always, in retrospect, it always looks inevitable. So there are two equilibrium states really in society. There's impossible and there's inevitable. And you tip between the two. And so we need to tip our apparently, but not, impossible situation into inevitable.
Dr. Martin Luther King said the arc of the moral universe is long, but it bends towards justice. And I think in this case, we're talking about a justice that isn't just for current beings, it's also for future beings. When we look at the world that our grandchildren and great-grandchildren will inherit, hopefully, if they are able to live on this planet at all, it will be because of the actions that we take today and our participation in helping bend that arc of the moral universe towards a justice of a world that works for them and for all beings. George, thank you so much for your sobriety and your heart and your hope and your leadership. We've been talking here today with George Monbiot, best-selling author, journalist, heroic environmental activist. And George, we are so grateful for what you're bringing into this conversation and for your partnership in the food revolution.
Thank you so much, Ocean. It's been a really great pleasure to talk to you. And thank you for providing a platform for these really important issues, because let's face it, most of the media does not.